Good afternoon, students. In the last class, we discussed graphs. So now, conversion graphs from XT to VT and VT to AT graphs, right? So take on these graphs. So first case X T. So here we have VT. Next AT. So for first case, when the object is at rest, so somewhere here the displacement that is at rest, then its velocity is zero, right? So any object which is, that means the line which is parallel to x-axis, then its velocity is always zero. If velocity is zero, again the acceleration is zero, right? So here V is zero, V is zero, right? Next. XT, VT, AT, right? So if the object starts from negative displacement, we get the equation like this. That is, straight line starts from negative displacement, right? So here we have minus x. So if we plot the slope, any point we get positive slope. That is, m is positive. So m is positive is nothing but velocity is positive. That means the object is moving with constant velocity, right? So here v is equals to constant. So object, we have the graph xt is in this form, then always velocity is parallel to the x-axis, right? So the object is moving with constant velocity, then again acceleration is zero, right? So next, third one, x t vt and again a. So the object starts from positive and end at negative. That means positive axis to negative axis. Displacement changes from positive value to negative value. So here, if you plot the slope, that is m is negative. That means the object is moving with a constant velocity, but the value of the velocity is negative, right? So in this case, we will write v is equals to constant in negative y-axis. That means here. So again here velocity is constant, then acceleration is zero here, right? So next, x t is combination of these two, right? So the displacement curve is like this. So what about velocity and time value? So here we have v, t, here we have a, t, right? So if you observe here, the displacement of the object from here to this point. So this is similar to this line, right? That means the velocity is negative. Here we get slope m is negative, right? That means the velocity is at negative, minus v. It starts from here. So at this point, the slope is zero, right? So here slope m is equals to zero. So slope m is equals to zero, nothing but velocity is zero. So exactly at this point, v is zero. Along time axis, velocity is zero. So now from here to here, if we plot the slope m, we get positive value. So this line is similar to this line. That means moving with a positive velocity, right? So start from here and it meets at. So we get the curve like this. So this is the straight line, right? So this curve represents uniform acceleration, because if you plot the slope here, we get m is positive. So m is positive, nothing but acceleration. That is, object is moving in a uniform acceleration. That is, a is constant, so its value is positive. So hence we plot in the first quadrant, right? So these are the conversion. So one more conversion, like this, right? So at this point, displacement here, slope m is equals to 0, right? So if you plot for VT graph, so if you observe here, slope m is positive, right? Next, here slope m is negative. That means starts from higher value and passing through the zero value and to the negative, right? So graph is so here slope is negative, m is negative. So here slope is negative means acceleration is negative. So that's why here we take a minus. Right? So these are the conversion of graphs from xt to vt and then vt to at. Right? So take down these graphs. This will be helpful while solving the problems. Right? So how many graphs we have? 5 graphs. Right? So let's move on to the problems based on these topics. For board exams, for 2 marks, they ask for any two graphs, that is increasing velocity or decreasing velocity, increasing acceleration, plot xt graph with increasing acceleration, plot vt graph with decreasing acceleration or retardation, right? So take down the problems. First one, a woman starts from her home at 9 a.m., walks with a speed of 5 kilometers per hour on a straight road up to our office, up to our office 2.5 kilometers away, stays at our office, stays at the office up to 5 p.m. and return home by an auto with speed 25 kilometers per hour. Choose suitable scale. Choose suitable scale and plot xt graph of our motion. Right. So here we need to find the XT graph. So here they given the details. First, a woman starts from her home, so she is leaving home at 9 a.m. and they given she walks with a speed of 5 km per hour. So on a straight road up to her office, that is 2.5 km. That means the distance from her home to her office is 2.5 km, and she covers that distance with a speed that is 5 km per hour. Right. So we need to plot x and t graph. So here they given in kilometers, so taken x in kilometer. So they only told in suitable scale, right? So time in hours. So the given distance or displacement. So the given distance is how much? 2.5 kilometer. So she travels with a speed that is 5 kilometer per hour. So she leaves at 9 a.m. So I will start from here, 9 a.m. Right? Next, stays at the office up to 5 p.m. So first, initially, what we are to find here means how much time she takes to cover this distance, right? So from that we know speed is equals to distance by time, right? So we need time. So we know the distance, that is 2.5 kilometer divided by the given the speed 5 kilometer per hour. So here kilometer get cancelled. So in the denominator hour goes to the numerator. So 25 by, that is 2.5 by 5, that is 0.5 hour. So she takes 0.5 hours to reach from her home to office. That means 0.5 hour is nothing but 1 by 2 hour. So 1 by 2 hour is nothing but 30 minutes, right? So from 9 a.m. to 9:30 a.m. so she reaches the office, right? So that is at a distance how much? Here somewhere 2.5 kilometer, right? So I will make the point here. At 9:30 a.m. she reaches this distance, right? So we get the curve. Next, so next stays at the office up to 5 p.m. right? So here time has changed. So scale starts from 9 a.m. So somewhere here I will take 5 p.m. So that means from 9:30 a.m. to 5 p.m. she is at rest. That means she stays at the office up to 5 p.m. So rest means she does not changes her position with respect to time. So she will be in this distance only, right? That is 2.5 kilometer, right? So up to 5 p.m. right? So next, she returns home by an auto with a speed of 25 km per hour. That means the distance from her home to office is 2.5 kilometer. So same from office to home again the distance is same, but the speed changes. So here in the second case, speed of an auto they given 25 kilometer per hour to reach her home, right? So now we need to find how much time taken to reach her home from the office, right? By the same, time is equals to distance by speed, right? So distance is again 2.5. So distance won't change from her home to office or from her office to home, but the speed is 25. Here it is kilometer per hour. So kilometer cancels. So hour goes to the numerator. So 2.5 divided by 25. So 2.5 you can write 25 into 10 to the power of -1 divided by 25 into hour, or its unit is hour, right? So 25, 25 get cancelled. 10 to the power of minus 1 is 0.1 hour, right? Again, we are converting into minutes, right? So 1 hour is 60 minutes. So 0.1 hour is 0.1 into 60 minutes. So we get 6 minutes to reach from our office to home, right? So again, somewhere here, the time is 5:06 p.m. That is, she reaches her home, right? So this will be X and T graph. The given information, from that information we are going to calculate or find the XT graph, right? So if you find the average velocity for this plot is how much? So if you want to find the average velocity, so from this graph, if you need to find the average velocity, so initial point here and final point is here, right? So in XT graph, all are lying in a horizontal. That means initial position and final position both are same because it starts at home and ends at home. That means initial and final point both are same. Hence, xf minus xi divided by t2 minus tf by ti. So it's become xi minus xi divided by time. So 0 by t. So average velocity is 0 because initial and final points both are home. That's why average velocity is 0. Right? Take down the second problem. So second one, a drunkard walking in a narrow line, walking in a narrow line, take 5 steps forward and 3 steps backward, followed again, followed again, 5 steps forward and 3 steps backward, and so on. Each step is 1 meter. Each step is 1 meter long and requires 1 second. Plot the xt graph. Plot the xt graph of his motion. Plot the xt graph of his motion. Determine graphically and otherwise how long the drunkard takes to fall in a pit 13-meter away from the start. Right? So this is the question. We need to plot XT graph, and here we are going to find the value of time. So first we need to understand the question properly, right? So here we are going to plot the XT graph. So given condition is a drunkard, right? So this one considering as a narrow line. So starts from origin, right? So here one drunkard is there. So he starts to walk. So it takes 5 steps forward, right? So for each step, that means for one step, it takes 1 second, right? That means he takes the time for 5 steps. How many seconds? 5 seconds. So next condition, and 3 steps backward, right? So when he moves forward again, he comes backwards. So how much steps? 3 steps, right? So for 3 steps again, it takes how much seconds? 3 seconds, right? So then his final point is here, right? So starting point, initial point is here, final point is here, right? So 5 steps, 3 steps. So the total displacement by the drunkard is how much? 2 steps, or 2 meters, or 2. Here they given in terms of steps, 2 steps, right? Then what about the total time taken from here to here? It is 8 minutes, right? Because 5 steps forward and he again comes back 3 steps. So 5 plus 3, 8 minutes. So 8 seconds, right? So for displacement 2 steps, he takes 8 seconds. Now this one we are going to represent in XT graph, right? So how will be the curve is suitable? Otherwise, how long the drunkard takes to fall in the pit? 13 meter. That means the starting point is 0. So somewhere here, 13 meter. Here one pit is there, right? So as he moves forward and backward and forward and backward, finally he comes and fall into this pit. So how much time he will take? We need to find, right? So first we plot the graph 2, 4, 6, 8, 10, 12. So here 14 takes in steps. So along x-axis, time in seconds, right? Now, so 0 to 5 seconds, cover how much distance? That is 5. So in between 4 and 6, here somewhere we have 5, right? So we cover, because each steps 1 second, 1 step 1 second, that means linear. For 1 second you cover 1 step, for 2 seconds you cover 2 steps, for 3 seconds 3 steps. Similarly, for 5 seconds you cover 5. Next, again for the next 3 seconds he goes backwards. So backward means, so 3 plus 5 plus 3, somewhere here we have 8. So he again comes back. So somewhere here. Right? So here it is 5, here it is 3. So next again what he did from here 5 steps, from 3 to 5, right? So somewhere 8 to 5. So somewhere here. steps backward means it becomes 3. So again from 3 to again 3 steps, right? 7 minus 3, 4, right? So here 8 plus 5, 13. 13 plus 5, so over here 18. So again from here 5 steps. So 4 plus 5, that is 9. So where here, that is 18, 23. Right. So next, again 3 steps back. 9 minus 3, 6. Here, 6. Right. So 23 plus 5, 28. Right. Next, again 5 steps. 6 plus 5, 11. 11 minus 3, 8. So again 8 plus 5, how much? 8 plus 5, 13, right? So this will be our ended. So here we make some correction. 28 plus 5, 33. Right. So 33 plus 5, how much? So this will be 30. So here is 8. So here we get, so 8 plus 8, we do this one 30. Directly we can take total net displacement 2. Right? So for net displacement, total time taken is how much? 8 seconds. So this gives 8 seconds, right? So again, from here to this point, 8. So 8 plus 8, 16, right? So again, this point 16 plus 8, 24. 24 plus again 8, 32, right? So here it will not complete. So here from here to here, it takes only 5 seconds, right? So 32 plus 5, 37. So this is the end point, that is 13 meter. So this is non-linear motion. So 5 steps forward, 2 steps backward. So when he covers 37 seconds, then he fall into the pit. So the trunker takes to fall into the pit, that is 13 meters, is 37 seconds, right? So these type of questions will not ask for main examination, just for converting the statement into the graphical picture. So these are the few examples, right? Okay, so next question. The velocity time graph of a body moving in a straight line is shown in figure. Find displacement. Find displacement and distance traveled. Find displacement and distance traveled by a body in 10 seconds. So they given the graph. So B, it is in meter per second. So time is in seconds. The graph is like this, right? So we need to find the, so it is point, it is 20, and here it is 10, again here it is minus 10, minus 20. So 2, 4, 6, 8, 10. Right? So we need to find the displacement and distance traveled. So they given the plot V and T, right? So as from the significance of the VT graph, the area under the curve gives what? The displacement, right? So first we divide this in two. So now this becomes one area, and again this gives the another area, right? So in a similar manner here also. Again here. So we need to find the areas. So area of 1 calling A1, A2, A3 and A4. So if we add all these 4 areas, we get the distance, right? So distance traveled. So in the same way, we get the displacement, right? So calculate. So 0 to 4 seconds, area gives the displacement or distance. So area A1 is equals to, it is in the form of triangle, right? So slope is positive, area is half into base into height. So this is the, so half into base is how much? 4 into height is 20, right? So we get 40 meters. So in the similar wise, A2, right? So A2 is equals to half into, so base is 6 minus 4 is 2. So this distance is how much? 6 minus 4, that is the displacement, that is 2, right? That is time. 6 minus 4 is 2 into height. So height is again 20, right? So we get 20 meter A2. Right? So next area A3. So this is 8 minus 2, that is 8 minus 6. The base is how much? Base is 2. 8 minus 6 is 2 into, so height is how much here? From here to here? Minus 20. Right? So 2 get cancelled. We get minus 20 meters. Next, area of 4, A4. So that is also in triangle. Half into, the time is, that is length, 10 minus 8, 2. Right? So 2 into height. So height is how much? 10. So again here we get 10 meter. So these are the areas. So first distance. Distance is equals to a1 plus a2 plus a3 plus a4. So we know that distance has only the positive values, right? So calling this one as s1, s2 or d1, d2, s3 and s4. So we know the distance has only the positive values, right? So hence we get a1 40 plus a2 20 a3 20 plus a4 10, right? So 40 60 80 plus 10 is 90 meter. This gives the displacement, sorry, distance, total distance traveled by the body, right? So next displacement, right? So displacement either positive, either negative, or it can be zero, right? So hence here we take displacement 40, that is plus 40, plus 20, next again minus 20, then again plus 10. So minus 20 plus 20 cancels. So the displacement is 50 meters, right? So displacement, here we get the negative velocity, that means velocity is negative, that means displacement also negative, right? So hence we take on displacement is minus, right? Next. So here if we find the velocity, so velocity is equals to displacement by time taken. So displacement is 50. So time taken is, initial time is here is 0 and final time is 10. So that means 50 divided by 10, we get the velocity 5 meter per second. Right? That is the average velocity. So here if you find the average speed, so they give a VT graph. So V and T. So graph is like this. So 0, here is 2, here we have 4, and at this point we have 7. It is in seconds. So at this point we have 8 velocity in meter per second. So find first one, average velocity during motion. So average velocity during motion. So next, second one, average acceleration. So the first one, between t is equals to 0 seconds to 4 seconds. Again that between t is equals to 0 seconds to 7 seconds. Right? So from this graph we are going to find the average velocity. So similar to the previous problem, right? So first we need to find the displacement. So here we have to find the area of each part. So otherwise, if you know the area of the trapezium, so this is in the form of trapezium, right? So if you know the trapezium, directly you can substitute and simplify in the trapezium formula. Otherwise, so this graph is divided into 3 parts, 1, 2 and 3, right? So here we're getting one rectangle and two triangles, right? So first displacement. So to find the average velocity, we have the time, but we don't know the displacement, right? So first we find the displacement. So that is A1 plus A2 plus A3, right? So area under the curve. So this is in the form of triangle, half into, so base is 2 minus 0 is 2 into height is how much? 8 plus A2. So A2, 4 minus 2 is 2 and the length is 2 and breadth is 8. So 2 into 8 plus A3. So 7 minus 4, 3 and height is 8. So 1 by 2 into 3 into 8. Right? So here 2 to get cancels. 8 plus 16 plus 12. Right? So that is 36 meters. So from this average velocity, so total displacement by total time taken. So initial 0, final 7. The displacement is 36. 36 divided by 7, right? So 7 5 is 35. 1 by 7 meter per second. So either we keep this one in the decimal form, right? 5.14 meter per second. So next, second one for solution, first one. So for the second, average acceleration. So average acceleration is change in velocity with respect to time, right? So they ask for 0 seconds to 4 seconds. That means the object starts from here and to here. We need to find the average acceleration from 0 to 4 seconds. So in 0 second, it's gradually increasing its velocity, right? So initially its velocity is 0, right? So when t is equals to 0, its velocity is 0. When t is equals to 4 seconds, its velocity is how much? 8 meter per second. So change in velocity is 8 minus 0 divided by, so change in time is 4 minus 0, right? So that is 4 minus 0. 8 by 4, 2 meter per second square, right? So that gives the acceleration. So in the second case, between 0 seconds to 7 seconds, right? So if you observe here, so this one is the 0 seconds. When t is equals to 0, its velocity is 0. That means its initial velocity is 0. After 7 seconds, so here again its velocity is 0. When t is equals to 7 seconds, again its velocity is 0, right? So that means average acceleration for second case, that is equals to 0 minus 0 divided by 7 minus 0. That is 0 meter per second square. Right? So this is how we are going to calculate the displacement, velocity and acceleration. Right? So in the next class, we will start with the important topic, that is equations of motion by using the graphical method. So very important for 5 marks long answer, right? We will continue next class. Thank you. So another doubts